Alright, so this is 4.4 day 2. We are still proving triangles congruent, and we're going to finish the last 3 shortcuts of how to prove triangles congruent. Remember from day 1, okay, or from 4.3, when we started with naming all 6 of the corresponding congruent parts, right, to figure out what are matching for congruent triangles. And then we talked about our first 2 shortcuts, right, where if I can prove side, 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 or side, angle, side, then I don't have to go through all 6 parts, right, because these are shortcuts to proving triangles congruent. Okay, so we're going to talk about the last 3 of these today, and the first one is angle, side, angle, or ASA. Okay, so again, when we are proving these shortcuts, right, and we're given these figures, we are not going to mark anything besides what is already marked for us, or a reflexive side or vertical angles. Remember, reflexive sides, a shared side, can be marked congruent, or a vertical angle can be marked congruent. But we are not just going to start marking our triangles. We're going to leave it exactly how they mark it for us. Okay, so when I play that little game, right, I'm labeling any angle that's marked congruent or with loops, and any side marked congruent with tick marks. So we have marked the loops with A's and the tick marks with S's, okay, so it spells out ASA for us. And just remember that when I check myself, right, if I were to go around the triangle in this direction, and according to the rules of the game, right, I cannot skip over more than one part at a time. So if I start at this angle and I go this way, I'm skipping over a side because there's nothing marked. I'm also skipping over an angle and another side, right? I can't do that. I can only skip one part at a time. So I have to go the other direction when I read the marks, right? ASA, okay? And it works for both triangles, so these are congruent by ASA, okay? Then we would list out our corresponding parts, right? Angle C, we'll start with one loop. So angle C is congruent to angle F. Side AC is congruent to side DF. And then angle A is congruent to angle D. So then I can write a congruency statement, right? Triangle, let's just say ABC, would be congruent to triangle. So remember, however I order the first, that's fine, but the second has to match. So I went 2 loops, no loops, 1 loop, 2 loops, no loops, 1 loop. So D, E, F. Okay, so let's just look at a few different examples of ASA. All right, remember, this would be like the entire process, okay, but we're just going to look at some examples of what ASA looks like, right? Again, we are not marking anything on our own besides vertical angles or shared sides, okay? These 2 triangles are completely separate, so I should not be marking anything that is shared or vertical to each other. Here's a loop, so I'm going to label it with an A. Here's a tick mark, so there's an S. Here's another loop, there's an A. Loop, tick mark, loop, it spells out ASA. Okay, so by ASA, let's do triangle ACB, right? So no loops, 2 loops, 1 loop. No loops, 2 loops, 1 loop would be DFE. Okay. We can also figure out congruent angles by their side measures, right? Because if we look over here, both of these angles have 1 loop, but we're given their side or their angle measures, right? So this is how we're going to differentiate which ones are congruent to each other. 30 and 30 are congruent, right? So there's A and A. 4.5 is congruent to 4.5, so these 2 sides are congruent. That's an S and an S. And then 53 and 53, there's A and A. So again, we just want to make sure that we're not skipping over more than one part at a time, right? ASA, ASA, okay? Let's look at these 2 examples, because this is where I don't have everything marked for me, okay? If I look at, I'm going to label this triangle 1, and this is triangle 2. If I start at triangle 1, I have an angle, right? Angle K is marked, and I have a side, okay? Side KG is marked. But nothing else on this triangle is marked. All right. Over here I have an angle and a side marked for triangle 2. The vertical angle at angle G can be marked, okay? Because remember, vertical angles are always congruent. I can mark them myself. So there's A and A for the remainder of those triangles. Okay, so by ASA, let's do triangle MKG, right? No loops, 1 loop, 2 loops. So I went 0, 1, 2. I have to follow that same order. 0, 1, 2, J, H, G. Okay, so this is an example of vertical angles, right? So vertical angles are congruent. Over here, okay, now this one is a good example. I have parallel lines in these two triangles, right? Those arrows on those lines mean parallel, okay? What I'm looking for are alternate interior angles, okay? Look right here. Angle D right here is going to be alternate interior to angle B down here. Those are congruent. I also have a shared side between those two triangles. Okay, so I'm marking that side congruent. If I were to turn the paper this way and look at these parallel lines, well then here is another set of alternate interior angles, right? This and this. So with those parallel lines, I have proved ASA because I have two sets of alternate interior angles. So alternate interior angles are congruent. Okay, so by angle, side angle. So now, this is a good example of how to name it because remember, here's triangle 1, here's triangle 2. Angle D for triangle 2 is not the same angle for triangle 1, right? I have 1 loop and 2 loops. Or angle B is not the same angle for triangle 1 as it is for triangle 2. So we have to pay attention to those loops. Okay, so I'm going to go 0, 1, 2. So A, B, D. And then 0, 1, 2 would be C, D, B. Okay, so the next one, AAS, angle, angle, side. Okay, so real quick, back to ASA, we have to make sure, right, that side is directly in between the two angles. This is the included side. Remember we talked about that. Included means directly in between. So this side that I've marked is right in between those two angles. Okay, because when I look at AAS, now I have angle, angle, side. The side marking is not directly between those two angles, so we can't get these confused, right? This is why we label it, because it spells it out for us. All right, so if I were to play my game here, I have an angle marked, I skip over a side, but then I have another angle. Remember, that is okay because I can skip over one part at a time. So angle, skip, angle, side, right? Angle, skip a part, angle, side. Okay, so we have to be able to identify the difference between ASA and AAS because that side is not going to be directly between the two angles. Okay, so let's look at another example of AAS. We have angle, skip over this side, which is fine, angle, side. Let's say I read it the other way, right, because it works this way, AAS. Angle, skip, skip, right? I can't skip more than two parts. A side and an angle creates two parts, right? Cannot skip more than one, so I have to read it this way, which it works, right? It works this way, so this triangle's good. AAS, right? I can skip over one part, and then I have my angle, but I cannot go this way because it skips, and then it skips again. Okay, so let's just name the triangle. So by AAS, let's say I do LMK, so 0 angles or 0 loops, 2 loops, 1 loop, so 0, 2, 1 would be TSU. Okay, here's an example of two right triangles that share a side. Remember, if it's a shared side, I can mark it congruent. So here we go. Here's a loop, that's an angle. I skip over this side, but I have another angle. Remember, all right angles are congruent to each other. So if you see, oh, that's an angle, not a side. So if I have 90-degree angles, right, I don't have to have loops on those because we know 90 is equal to 90. So AAS, AAS, right? We skipped over one side, but that's okay because I can skip over one part at a time. Okay, on this figure, I have vertical angles at T, so I'm going to go ahead and mark those. AAS, AAS, right? So I'm reading it this way, AAS, AAS, right? If I read it the other way, I would skip and skip. Can't do that, so I have to go angle, angle, side. Okay? Now, right here, this is a great question. It says, what else do you need to know to prove that the triangles are congruent by AAS? So if I look at my figures right here, I have an angle marked and a side marked. I want to prove AAS, okay? So this is a great question because we have to figure out, well, which angle, right? Because we have an A and an S, but we're missing that other A. I have to figure out which angle between T and W, or between X and Z, is going to create AAS. Remember, I don't want it to create ASA. Okay, they're different. So if I were to mark angle T, let's just say I marked it, that would create ASA. I don't want that. Can't be T. It has to be W. Because look, A, skip over a side, right? It's only one part. Then another A, then S. Okay, so it has to be angle W, right? And we're going to figure out, well, what's the angle over here that would make that the same, okay? If I marked X, that would produce ASA. We don't want ASA. We want AAS. So it has to be angle Z. So this is a great question, okay? More, probably like a test-like question, right? Figuring out what is the missing piece to make that congruence postulate, right? AAS. So going through and kind of recreating the game and figuring out which one works, you're figuring out what are the two missing pieces, right, between both triangles. Okay, our last postulate, HL, this obviously applies to right triangles only because a hypotenuse is only located in a right triangle. So hypotenuse leg, okay? If I can prove that the hypotenuse, which remember guys, the hypotenuse is always located across from the 90-degree angle. If the hypotenuse is congruent and a corresponding leg of two right triangles, then I can prove congruence, okay? It has to be the hypotenuse, right, across from the 90-degree angle, and a corresponding leg, meaning a matching leg, okay? So the leg has to match. And the reason why this congruence theorem works is because think of a squared plus b squared is equal to c squared, right? If your hypotenuse is the same, well then guess what? C squared is the same. If your A or your B is the same, well guess what? The other one has to be the missing piece that's the same, because mathematically it has to equal the same thing, right? 3 squared plus blank squared is equal to 5 squared, right? It has to be that same number in order for it to mathematically be correct. Okay, so we're proving HL, all right? They have to be right triangles, right? So yes, I'm going to have a right angle, but I'm not going to label that with an A if I'm trying to prove HL. So if I look across from my right angle, that's my hypotenuse. This is the short leg, right? I have a short leg and a long leg, okay? Here's the hypotenuse, and this is the short leg. So this is HL, right? Let's just say I name it triangle ABC. So I went from the 90-degree angle across my short leg, then along my hypotenuse, right? ABC. So 90-degree angle across the short leg, then the hypotenuse, so X, Y, Z. All right, so we're going to pause right here, go to part 2 for the remainder of this video. Okay, so if I look over here, right, I have a 90-degree angle at T, which means that this is a 90-degree angle right here because vertical angles are congruent. So if I look at my marks, this is the hypotenuse for each, right, across from the 90-degree angle, and then I have a leg, okay, for each. Okay, so by HL, then we would write our congruency statement. Okay, these are great examples, all right. Now, we have a right angle, which means there's a right angle right next to it, right, linear pair, 90 plus 90. My hypotenuse for each is marked, but I don't have a leg marked, right? However, they share this side. So guess what? This one leg is going to be the same for both triangles, so I have proved HL. Okay, now, this is the difference here, right? Kind of the same figure, but my hypotenuse is not marked over here. Here's a 90-degree angle. This is a 90-degree angle, right? We have a leg marked, okay, for each, but my hypotenuse is not. Okay, so I don't want you guys to think, oh, it's not congruent because I can't prove HL, right? HL works for right triangles only, but that doesn't mean that the other ones can't also work for right triangles, okay? Because a 90-degree angle is still an angle. So I don't have my hypotenuse marked, so I can't prove HL, but I can try another one. This is a side, this is an angle, they have a shared side. So even if I don't prove HL, I can still prove another postulate because a side and an angle are still a part of right triangles, right? So what I've just proven is SAS. Okay, that's a very common thing that you might come across with right triangles is if I can't prove HL, well then I should look for SAS. Okay, so let's do these two proofs and then the notes will be done. All right. Here's my given information, right? We have all of our reasons, so I'm going to list my given, okay? CD bisects angle ACB. So I'm going to write that down in statement 1. Okay, so what that means is that this segment is bisecting angle ACB, okay? So this segment is splitting in half this entire angle, meaning angle 1 and 2 are congruent. That's what I'm going to write right here. The measure of angle 1 is equal to the measure of angle 2 because of that angle bisector, right? We had an angle bisector, it split that angle up top in half, so we can conclude that 1 and 2 are congruent from the definition of an angle bisector. My next reason is reflexive, okay? That means that shared side. So I'm going to mark my shared side congruent, and then I'm going to state that side CD is congruent to itself because that's the reflexive property, right? When something is congruent to itself. Then I have another given. Here's another given right here. The measure of angle 3 is equal to the measure of angle 4. Okay, I'm going to just mark those congruent with 2 loops, right? Because I've already used 1. So now what I can state is that angle 3, angle 3 is congruent to angle 4, right? Because if something is equal, then they are congruent, right? That's kind of like 4 and 5 are very similar. It's kind of the same statement. If the measures are equal, then the angles are congruent. Okay, so look what I just proved. ASA. ASA. So this is my reason, but I'm going to state what 2 triangles are congruent because of ASA. Right? I've proved the triangle's congruent because I've formed one of my 5 postulates, right? ASA. So let's say I do triangle CAD. Well, this triangle is congruent to CBD. You have to make sure the order of your second triangle follows the same way, right? 1 loop, no loops, 2 loops, 1 loop, no loops, 2 loops. Okay, so there's my triangle congruency statement. Look at this 7th reason, right? Because they didn't want me to prove that triangles were congruent, okay? It was a part of my proof, but this is my proof statement. Side AC is congruent to side BC. And here's my reason. CPC, TC, corresponding parts, right? AC and BC are corresponding parts, right? Look at my order. CA, CB, right? First and second, first and second. Corresponding parts of congruent triangles. I've proven the triangles are congruent in statement 6 are congruent. So this is a good little proof, because once I've proved triangles congruent, remember this is a shortcut, right? Once I've proven triangles congruent, now that means that all of the other corresponding parts are going to be congruent, even if they're not a part of my shortcut. Okay, so last one. We have the statements, we have to provide the reasons. Okay, angle E is congruent to angle J, that was given to us. They are marked with that loop. Okay, I'm going to put an A on both of those. Okay. The next given that we have is EF and JH. That's in statement 3, so reason 3 is going to be our next given reason. Okay, and then EF and HJ are marked with a tick mark, so I'm going to put S. Let's look at statement 2. EGF, angle EGF is congruent to angle JGH. What they've marked are the vertical angles, right? So this reason is because vertical angles are congruent. Always. We can always mark vertical angles congruent. So I'm going to put A next to both of those. We have to figure out, how did we prove these triangles congruent, right? What postulate did I just prove? Do you all see how my proof, right? We are proving the triangles congruent here, so that's as far as I need to go. I'm going to list out which postulate did I just spell out. A, S, right? I skipped over this one side, but that's okay. S, S. So this is the postulate that proves those two triangles congruent. So just make sure you know, if your prove isn't a triangle congruent statement, right, you have to still prove those triangles congruent along the way, but when I can prove something else outside of that postulate, I'm using CPCTC. But when I'm just proving triangles congruent, then I'm stopping, right? I'm using one of my triangle congruence postulates and only proving the triangles congruent.